Hi, I'm Catherine Moriwaki, Associate Professor of Media Design.
Hi, I'm Xing. I am an Assistant Professor of Interaction and Media Design. So this week in Critical Computation, we are going to talk about artificial sensing. Particularly, we are going to explore how machines take information from the real world. And in this case, we are going to talk about computer vision and understanding how a machine sees and how it taking the information that it sees and turn it into decisions. So here what you're seeing on the screen is a video created by Adam Harvey, the artist who made CP Dazzle that we talked about last week. And in this video, we start to get a sense of how Opencv, which is an open source library that lets you integrate facial recognition system into your software, actually works. So what we see on the screen here is how a computer reads an image, right? So in comparison to human eyes, where if we see a JPEG or a picture on the wall, we might be processing every single color value, shading, and pixel all at once. In the case of computer vision, a computer actually processes image in a very different way, and specifically from left to right and up to down. And it also processes every single pixel individually and translating them into sets of numeric values.
And so this image is actually very interesting. It is an image or photograph of Lena Forsen, who in 1973 posed in posed for an issue of Playboy magazine. This image was chosen by image processing researchers to use in order to engineer the file format that would eventually become the JPEG. What's really interesting about this is that Lena Forsen herself never had any idea that her image was used in order to facilitate signal processing research. Furthermore, she was also entirely unaware of the fact that after using her image to engineer the JPEG format, that this picture of her became the default image upon which any kind of image processing was undertaken. So anytime within the image processing field, people were processing an image or looking at algorithms to render images, more often than not, they were using this image of Lena Forsen. And so there's this interesting kind of situation here, in which Lena is no longer really seen as a person, but is reduced to basically an artifact, an image.
Here is a diagram that basically maps the discipline of computer vision. It's definitely one of those computational topic that has a lot of practical applications from medical to our everyday interaction with our smartphone cameras, or maybe a seemingly innocuous app that would detect where your faces are on the screen. So it's really once we start thinking about how computer sees and what it can see, it's all around us and making all kinds of important decisions. So here, this is another example of just looking through how, some of the nuances of how this happens. We have learned a little bit about color and how color work in P5.js in one of the tutorials. In every single screen pixel, there are 8 bits of memory, and each of these pixels then get represented onto the computer screen. There are a couple of steps that are practiced through the process of computer vision. The first step is called image segmentation. And this is the process of recognizing the edges of a shape. So if a computer camera is able to scan every single pixel and figure out where the edges are, it then can essentially figure out where the boundaries of objects are. And there's another process in computer vision is finding corners. So by being able to find the corners of objects through edge detection, you can also start simulating perspectives and camera angles, right? So there's all kinds of application and usages of this. The kind of final step that comes out of this oftentimes is the ability to make guesses for the computer. So being able to distinguish where a person begins and where a helmet ends, and where does a road begin and where does the motorcycle end, is what a lot of computer vision study and research goes into. Here is one of the most maybe widely discussed application of computer vision, which is the autonomous cars. And I see Catherine smiling. and there's, on the left, you see a simulation demonstrating how a car with a computer vision ability theoretically able to distinguish the differences between another car versus another human versus a person on a bike, maybe versus a statue versus a building. And what kind of comes out of this that's really interesting and sort of a heated topic among people who are studying computer vision, but also the ethics of computer vision, is thinking about what does it mean for a computer to make an ethical decision when it comes to accidents and like risk prevention. So on the right, I've added this image that illustrates the trolley problem that oftentimes brought up in ethics classes. This thought experiment asks if a person is able to operate a trolley on the railroad, and it's able to, this person is able to make a decision on whether the trolley is going to steer left, therefore saving 5 people who are on the right, but also knowing that the person on the left is going to die if this operator steer left. Would this operator still do it? So this is kind of a ethical thought experiment, but it's also very applicable to the autonomous car, right? So if a autonomous car is able to see multiple objects at various distances, able to make prediction, and if it's able to predict a couple of steps ahead, what would a computer do? And what's the ethical way to approach like real life issues relating to accidents?
This particular project takes advantage of how an autonomous vehicle might be programmed to follow the directions of traffic lanes that have been painted onto the road. And so in this case, the vehicle sees the dash line in the outer ring and the solid line in the inner ring. So the vehicle basically senses that it's okay to cross the line and go in to this circle that's drawn. However, once the vehicle's actually in the circle, there is a solid line with a dash line around it, thereby indicating that you're not supposed to cross over that marking in order to merge into, say, for example, a lane. But in this case, this marking is circled around the vehicle, thereby entrapping it.
So let's actually start talking more explicitly about how computer vision and the development of computer vision have affected human. Specifically, we're going to start with the human body. So on the left, you're seeing screenshots from actually a early development of a computer animated hand. It's actually one of the earliest 3D animation created by Edwin Catmull at the University of Utah. And at the time, there was, no 3D scanning and there was no Maya. There was no real way of like creating a 3D model through a graphical user interface. So what Edwin here figured out was to actually draw lines and vector points onto a real human hand, and essentially using a machine to document every single coordinate on that hand. And that was sort of the creation and the start of thinking about how bodies can be vectorized. And a lot has happened, and a long way, between the first computer animated hand to the most recent invention with iPhone X, where you could actually unlock your phone with your face, right? And the way, even though it's using different kinds of technology, the principles is actually very similar, in the sense where on the right, there's actually, like thousands of little light beams that gets projected onto your face, and the information that it receives in terms of the position and the relational positions between your eyes, your nose, your lip, and your face contour can actually give the computer, in this case the iPhone, enough information to verify the authentication, the authenticity of the user. So thinking about how the human body sort of became vectorized and translated into a series of numbers and digits. And what we are seeing here, it's a data sheet and identification card that really is a predecessor of the kind of biometric surveillance system that we have today. It was created by a French police officer and biometric researcher, Berthelon. And in this case, Berthelon have found a way to combine the kind of anthropological researches that people were doing at the time, and most of them really problematic, by essentially indexing different kinds of human features. He found a way to combine those techniques with the field of criminology, documenting someone who were seen as a criminal by the justice system at the time, and trying to pair biological features with criminality.
This is a project by Heather Dewey-Hayborn titled Stranger Visions. And it was a project that really looked into the fiction, if you will, of DNA analysis. So the artist went around New York City and picked up objects that people might have discarded on the street and used those objects to then analyze their DNA. And with that DNA analysis, began to construct portraits of these strangers. What was really fascinating about this process is not a straightforward process. Actually, part of what Heather was trying to explore was the kind of the fiction and the speculation involved in actually constructing identity from biological data. And in fact, the models that she used to actually build these faces had a range of different possibilities, were actually rather fluid in their interpretation of what the DNA could mean, and were in fact actually shaped by her artistic and aesthetic choices. And so we're actually going to link to a presentation about the project here in the lecture, and you can view it, and you can actually see how there are various different models of sort of DNA expression and what that might mean for facial features. And if this is a very evocative project, which really then called into question of the sort of speculation, the imaginary, and in many ways too, the kind of false belief that we have in the infallibility of science to be able to tell us what it is that we're seeing and what actually exists in the world.
That last bit relating to fiction versus evidence is fascinating, because what she was also pointing to is calling our criminal justice system into question, right? And that the kind of science and DNA analysis that the police have is not necessarily very far off from what she did here. and there are a huge level and area of ambiguity when it comes to pinpointing a suspect. So in this video essay called How Not to Be Seen by Hito Stereo, made in 2013, it's referring to the satellite surveillance that all of us inevitably go under, and how in 1996 the photographic resolution for a satellite target was measured by 12 meters per pixel. However, in 2013, it is 1 foot. So in a way, there is no way for any of us not to be seen. As much as we might resist CCTV, there is a bigger, more higher res camera out in the space constantly watching us, right? So this video is a playful sort of exploration on how small do we have to shrink? Our human bodies would have to shrink in order not to be seen. Here is a video essay by Zach Blass called The Facial Weaponization Suite from 2011 to 2014. It's a video essay that comes along with a series of workshops that happen over time. I'll link the video essay here that you can please go watch them. But what Zach Blass is talking about is looking at a brief history of the criminalization of queerness, specifically through facial recognition. So it was a research conducted at a top university, and the researcher believed that by analyzing and sorting imageries of gay men, there is a way to basically predict like who is gay and who is straight. And so these kinds of unquestioned design of algorithms is very much embedded in the field of criminology and in the field of facial recognition. And here is another example, ongoing project that started in 2014 by Harris Kornstein. And basically in 2014, Harris had noticed a very curious and peculiar Facebook trend where drag queens who were posting screenshots were actually incorrectly being tagged by Facebook as one another. So their faces were actually like Facebook was actually confused about who's who and tagging them as one another. And so it was a kind of revelation of a technique of how one might possibly use the drag queen makeup as a way to escape biometric surveillance. So what Harris has been doing since 2014 is creating and designing a whole catalog of looks for drag queens that one can possibly wear to escape biometric surveillance. And we're going to talk about a couple different more examples of the relationship between biometric surveillance and queerness. And I think this idea of the normalized body is very much at the center of the discussion. So whose body is seen as normal, whose gender behavior is seen as normal, and what are the kind of punishment that comes along with individual who might fall outside of that or transgress that. So here is another example by Shuli Chang. 3 by 3 by 6 is a large scale installation that took place at the Venice Biennale at the Taiwanese Pavilion. And what Chang did here was that she created 10 different research narratives on 10 different individuals historically who had gone under surveillance and had been punished, whether it's for their sexual or gender expression that didn't match the expectation of the normalized body.
Shulei Chang is also very well known and widely regarded for a commission that she received from the Guggenheim, the first ever online commission for her project Brandon, which was a website, a work of net art. And the project basically explored the story of Brandon Tina, who was a transgender man who was tragically murdered and raped when he was discovered as being trans. And the work is meant to look at fluidity, the ambiguity of gender and identity, and at the same time serve as a kind of forum for evolving conversation. So the project lasted for about a year, was also a host for conversation, for academic discussion, and really as a vehicle to explore gender identities that fall outside of harshly defined binaries, and also to draw attention to the extreme violence and aggression that individuals who basically fall outside of these binaries oftentimes experience in the practice of the patriarchy wanting to essentially limit, control, and punish bodies that fall outside of normative standards. And so we would be remiss in mentioning Brandon Tina's story, if we also didn't call to attention the levels of violence and danger that trans women of color, and more specifically Black trans women of color, experience. So these are the photographs of Brayla Stone, Mercy Mack, Shaki Peters, Drea McCarty, Tatiana Hall, and Bree Black between June 25th and July 3rd. This doesn't take into account the total number of trans women this year who have been found murdered, the vast majority of whom were Black. There are still discrepancies in terms of racial hierarchy and in terms of the amount of attention and public outpouring of both concern, support, and indignation when it comes to even queer bodies. You see discrepancy between the valuing of whiteness over Blackness in these kinds of situations.
Okay, so the next project here, called Gaze Makes the Glitch by SciX, created for coding societies at the School for Poetic Computation. Here, Sci is very much thinking about how glitch can be used as a way to address the gaze from white supremacists on top of Black bodies. So I think it's really interesting to juxtapose glitch with computer vision, right? Because computer vision is always sort of positioning itself, at least in the kind of like neoliberal techno narrative of bringing technology closer to the human consciousness and the human mind, where the glitch is very much a kind of resistance towards that, or kind of disruption towards that. And this video on glitch feminism, and there's also a glitch feminism manifesto written by Legacy Russell, and also a book called Glitch Feminism that just recently came out that we would highly recommend checking out. Very much thinking along the lines on how glitch as a medium and a technique can be used to process deeper on issues relating to representation, and also pointing towards how the ideas of representation and the ideas of naming and of labeling is very much a Western concept, right? So thinking about glitch as a way to not be seen and not be interpreted in the Western colonial terms is also another way to think about the issues that has been discussed so far in this lecture.
Glitching at the level of software. So it was mentioned earlier before about how sort of the pixels work, how images are constructed for the screen. And so because that is a numeric process, that is a coded process, one can actually also go into the code that instructs the machine how to display images and disrupt that system. So this is a project called Data Moshing by Phil Tucker. It's actually not necessarily a project that contains artworks. It's actually rather a website with tutorials for how individuals can actually mosh their own data using a variety of different technical strategies. And so it's just fascinating because they're at the level of both, glitch works at the level both conceptually as well as truly technically. And glitches are considered to be mistakes. Glitches are undesirable typically in the smooth operation of a coding schema. And yet at the same time, there are, as we've been mentioning in this lecture, numerous examples in which those mistakes are celebrated, those mistakes are sort of utilized and taken up as a tactic of resistance. And also as just very interesting aesthetic and code-based investigations.
What I find really interesting from what you just said is how, I haven't previously considered this before, but how data matching can also provide a possible entry point in thinking about producing non-human centric knowledge or aesthetics or ways of being and in a way like questioning what does a good glitch look like or what does a good glitch even means, and to whose eyes, and based on what parts of aesthetic history is really interesting.
And so this is a quote by Edouard Glissant in Poetics of Relation. And this quote says, "If we examine the process of understanding people and ideas from the perspective of Western thought, we discover that its basis is this requirement for transparency. In order to understand and thus accept you, I have to measure your solidity with the ideal scale, providing me with grounds to make comparisons and perhaps judgments. I have to reduce." We found this quote to be very compelling in the context of this week's theme, primarily because of the way in which, in this particular essay, Glissant is actually arguing for the right to opacity, is how he frames it. The right to not have to explain oneself, the right to be able to maintain and control one's inability to be understood, and also a respect then for that difference. And that in fact, actually, oftentimes in this quest to be understood, to have one's subjectivity, one's way of being understood by others, that actually what this is a submission, in a sense, to the Western rationality, Western colonial thought that says you have to open yourself up to be measured, to be judged, to be placed into a schema. And that in of itself is actually a kind of violent and brutal act. And so this actually relates quite a bit to, glitch feminism, to works that explore the glitch, because at a technological level, what this is actually saying is that there is a right, in a sense, for the creator and for the, for creators and for artists and for marginalized people to assert that autonomy at a technological level, to thwart surveillance systems who would, that would measure and that would judge and that would exact according to a scale, and that this in fact is a way to reclaim a part of oneself, a way to basically assert oneself in the context of totalizing systems which would lay bare all that's visible, but do so in a way that actually reinforces existing norms as well as hierarchical power structures.